Problems 7, 8, and 9 are going to allow us to solve these systems any way we want. And the fastest way, or the best way I know of, is to use some kind of calculator to do it. I don't want to have to show all my work. So I'm going to start with number 8. I know 7 does something kind of strange, so I'm going to start with number 8. What I'm going to do is let's go to one of our calculators. So we're normally at a matrix calculator here. Let's just type in Gauss Jordan calculator. Okay, I think this Reshish does a pretty good job. And so we've got a Gauss, we've got to set our matrix dimension, and it was a 3 by 4. And so then problem number 8, where were we? Problem number 8, just throw in the coefficients. It was -2, 4, 3, 1, 4, 3, 6, 36. -5, 2, 2, -9. And we're going to solve. And give me some weird looking decimals. You have to be smarter than the calculator at sometimes, I guess. To me, this looks like 3, -2, and 5 would be the solution. 3, -2, and 5. If you want to go through and look at the solution process, click on that button. It gets a little bit messy there. But what did we say? 3, -2, and 5 would be the solution. So this is 3, y is -2, and z is 5. So we're going to do basically that for all 3 of these problems. Let's do number 9 next. Number 9, I think we need to go back and set the matrix for number 9. 4, 3, 4, -11, 5, 4, 6, -14, 9, 7, 10, and 5. Solve. This one is inconsistent. If you were doing this by hand, you would be looking for your final matrix. You would be looking at one of the rows does something weird. This row right here basically means 0 equals 30. 0 equals 30 doesn't make sense. That's mathematically inconsistent. And so what that means is no solution. We know that's inconsistent. We know that's going to be no solution. Now there are 3 possibilities. Usually we have one answer. That's the one we kind of like. No solution. That's not too bad. We recognize it because we can say like 0 equals 30 or something that doesn't make sense. The other one's going to end up being many solutions. Usually we'll recognize it as a mathematically true statement. But I think this one's going to be many solutions. Let's see what happens when we plug it in. I believe it was a little bit weird. Let's set that matrix. This is number 7, 3, 5, 6. And you can kind of tell what's coming if you add the top 2 rows together. Notice if you add the coefficients in the top 2 rows, it's going to equal exactly the coefficients in the bottom row. There's a 7 there, and there's an 8 there, and there's a 45. That's kind of a clue. 33 plus 12 is 45. When you add all these straight down, that's kind of a clue that something weird happens. Here's what's wrong is it makes you think there's a solution, but there's not actually a solution. Let's look in here. Here's what's weird is it makes it look like there's a solution, but there's really not. So I don't know. I think there's a problem with their website. Let's try and see a different one. If you go to matrixcalc.org, let's change to English. I don't know Russian. And let's solve a system of equations. I'm going to make it into a 3 by 4. Let's see what this one says. There are lots of different places out here. You just have to find a resource that works for you and that you can understand and is easy to use. I'm going to solve by Gauss-Jordan elimination. And this is really hard to read, but they're taking you through their Gauss-Jordan process. And if you notice the common decision, they've got this weird looking thing right here. This is basically the general form of the many solutions. If you look at their final Gauss-Jordan matrix, you can see down here this bottom row says 0 equals 0. This is more like what I wanted. This is a little bit more like it. This is what we'd expect to see normally. 0 equals 0 is going to kind of be the key that tells us that this is many solutions.